We're starting chapter 3 talking about elements. So this chapter we get to talk about elements, compounds, and mixtures. So we're going to be learning about the difference between these. So we're starting off with our simplest form here. An element, by definition, is a pure substance that cannot be separated into a simpler substance by physical or chemical means. So in an element, it only has one type of atom. It has whatever that element is, whether it's gold, it's oxygen, it's hydrogen. That substance, no matter if you have an ounce of gold or you have a ton of gold, there are only gold atoms in there. It's a completely pure substance. So we have a periodic table, which we'll get more into in the next couple chapters, that is full of elements. So we have over 100 different elements that, or 100 different substances that are considered an element. So they all have the same type of atom, no matter how much you have of it. Each element has specific properties. Remember, we talked about characteristic properties being properties that are unique to a certain substance. So examples could be, there's certain elements have a higher boiling point. So they have scientists have done research and find maybe it has a boiling point of 123 degrees Celsius. It's just a number I'm coming off the top of my head, but that element will always have that number as their boiling point. A lot of elements will have the same color all the time. They'll have the same texture, whether they can react with certain substances like acids. So these are characteristics that stay with them at all times. They don't ever change if you're looking at that element. We have 3 different types of elements that, again, when we get into the periodic table more specifically, we will see that they're broken down, that periodic table is broken down into and kind of separated by these 3 types. So our first type is metals. All elements that are metals are shiny. They are good conductors, so they conduct electricity well. They are malleable, which means they can be hammered into sheets, so they're flexible, able to mold. They are ductile. We have talked about ductility. Remember, the ability to be pulled into wire. So again, it can be molded. And so we've got a lot of examples. There's a ton of metals on the periodic table. Metals are the most common type of element that we have. So examples, we have copper, lead, tin, gold, silver, sodium. They're all examples of metals. So we'll get to see some of those here in some of our upcoming labs. Okay, so our next biggest group of elements that is on the periodic table are called nonmetals. So these basically have the opposite qualities of metals. So they're not shiny, they're dull. They are poor conductors, which means they are good insulators, so they don't conduct electricity well. They're brittle and unmalleable, so they can't shape them really. They're going to, if you were trying to hammer them to sheets or bend them and try to pull them into wire, they would just break. They're very fragile. And then another thing to know about them is that there's not a lot of nonmetals out there that exist on their own. There's not a lot of objects out there that we use that are simply made of just a nonmetal. Especially because, one, there's not as many nonmetals as metals, and because a lot of them exist as gases, so we don't have a lot of objects in our daily life. Where metals, we use them for wire and technology. Nonmetals aren't quite as prevalent for us. So some examples, iodine, sulfur, neon, hydrogen, oxygen, they're all examples of nonmetals. Some that are essential, just not as common for us to be using. And our last group is called metalloids. So this is basically just a mix between the two, metals and nonmetals. There's a small section of metalloids. There's not a whole lot of these, but their qualities they can have metal qualities, they can have non-metal qualities, but one thing about them is they're considered semiconductors. So they're kind of good at conducting electricity, but they're not as good as a full-on conductor would be. So it kind of insulates, kind of conducts. But beyond that, the element could be shiny, it could be dull, it could be brittle, it could be malleable. It's just, if you have something that has a quality of both metals and nonmetals, more than likely you're looking at a metalloid. So a couple examples of these are boron, silicon, and antimony. Okay, so for extra credit, to see if people are actually listening to the video here, I want you to draw a star at the top right corner of the front side of this paper here. Again, this is extra credit to test if people are actually listening.